exponential solving. So what's going to happen is you're going to be given some type of base, like a number, to an exponent, a variable. And we've never had to solve anything to an exponent before. We slightly did in geometric series and sequences from grade 11, but it was very, very basic. So what we're going to look at now is, if I give you something like this, and I say solve 3x equals 9, let's say, how can I figure out what x is? So we're going to be able to do common base, which we're going to look at today. We're going to learn how to convert to logarithms as well. And we're going to learn how to check with our calculator. So there are 3 ways we could solve this. Common base is the first way we're going to go over. Common base only works if you can make a common base. These little numbers down here are called the bases. This is the base of the exponent. So if you can make common base, you do that. If you can't make common base, we're going to have to take the log and convert it. Okay? We can check with our calculators. Taking the log and converting always works. Common base doesn't always work, but it's faster. So I always check, can I do common base? If I can't, I convert to a log. Okay? So I'm going to do common base first. So all the solving we're going to do for now is common base. So what the heck does that mean? Well, if I give you 3 to the 2 equals 3 to the smiley face, what could you tell me smiley face equals? Smiley face must equal 2, right? Because I have common bases. In order for that to be true, the exponents must equal. Would you agree? So, number 1, what's our problem? The bases are not common. Can we make them common? Yes. How do we make them common? We make them smaller bases. We never make them larger bases. So we're not going to make them both be 9. We're going to make them both be 3. We always make them smaller. Okay? So this one stays the same, 3x. And 9 is 3 what? Squared. Now what could you say x equals? X equals 2. Now we can check it 2 ways. We should be able to walk away from every single one of these questions and know we're right or not, because we can check them. So I'm going to check it by actual algebra. So we go 3 to the 2 equals 9. And when you check, it's like a proof. It's like a verification. Check is another word for verification, correct? So everything on the left follows down. Everything on the right follows down. You see if they equal. So 3 squared is 9 equals 9. And we know we're right. Another way to check this is I told you that it doesn't matter what unit we're in. It doesn't matter if we're in trig, or if we're in polynomials, or if we're in logs and exponential, or if we're in radicals, rationals, and other functions, which is going to be the last unit. If we have something equals something in one variable, we can y1, y2, and find out where they intersect. Every single time, doesn't matter what unit we're in. So right now we have 3 to the x equals 9. So I can just go like this. I have something equals something in one variable. So y1, y2. Plug them in. y1, y2. And then you do second trace 5, enter, enter, enter. Now, sometimes your window can't be correct. It's too small or stuff like that, and you don't find it. So y1, y2 is a great way to check. But if it says anything algebraically in a written response, and you y1, y2, and you give me an answer, how many marks are you getting? 0. You're not even getting 0.5. If you literally answer a written response with just an answer, and it says algebraically, and it's out of 3 marks, mind you, or 2 marks even, and you just put an answer, do you think you're getting anything? No. And if you thought you're getting something, you haven't listened to me, because I've said it all year long, that if you just put an answer on an algebraically, they will give you nothing. That was confirmed to me. It will not happen. You will get 0 marks. Okay? So don't be like, well, I'll chance it. It's not, don't. You're going to get 0. There's no chancing. Okay? So this one's a really easy one. What happens if we make it a little harder? So the whole thing of all of these is going to be solve. What does solve mean? Determine what the variable equals, right? So in the end, whenever I say solve, I look for what the variable is. Oh, in this case, it's x. And in the answer, I need x equals, right? So in a proof, when my variable is theta, and you do the whole proof with x's, should you get any marks? No, because your question had theta, and you have x's. You didn't even follow it. If you give me non-permissible values that say x cannot equal something, but the variable is actually theta, that's great. You found x cannot equal something. I don't even know what x is. X was not even in the question. So that was great. You found that x can't equal that value. However, it's theta because the question had theta. So you have to use the variable they give you, right? Right. 90% of you are not. So keep that in your head. So if your proof has x's, you use x's. If your proof has thetas, you use thetas. If your proof has x's or thetas, use something. Some of you just write sign with nothing beside it. That's really bad. That's like worse than putting an x, actually. Okay? 2. 9 to the x minus 1 equals 27 to the x. So for all these cases, we're doing common base. So we somehow have to get a common base. And remember, we always get a smaller one. So what's common to these two? Remember, you always have to make them a base. So a base means that number to an exponent. So some people will say, well, 9 is, or 27 is 3 times 9. So I'm going to go 9 times 3. Is that helpful? No, we have to make it a base to an exponent that they match. So what base can I make them both be? 9 is 3 squared, and 27 is 3 cubed. Some people go 9 times 3 and then put the 3 up here. That's not helpful. We need them to be the same base. So 9 I can make be 3 squared. What do I have to remember to do here? Bracket the x minus 1. If you're someone who's like, oh, I wouldn't do that, leave yourself a little side note and say that you have to put the exponent to both of those variables. Correct? I bracket it so I don't forget. And then 27 is 3 cubed times x. So you have to remember to distribute that 2. Do you think they're going to give the answer if you forget to distribute the 2? Absolutely will. So we can distribute that in, and we're going to get 3 to the 2x minus 2 equals 3 to the 3x. Now what can we say? If we have 3 to this exponent equals 3 to this exponent, what can I say about the green things? They must be equal, correct? If 3 to the something equals 3 to the something, this something must equal this something. So at the next step, once I have common bases, I can just put my exponents equal to each other. 2x minus 2 equals 3x. Because they must equal if my bases are the same. And then I'm just back to grade 9 and 10 solving. So subtract 2x. Negative 2 equals x. Now I hope I'm right. Is hoping you're right a good situation? No. Is checking you're right much better? So we are going to check it or verify it. So it's going to be 9, negative 2 minus 1 equals 27 to the negative 2. And 9 to the negative 3, I think, is 1 over 729. Yeah? No? Could be totally wrong. Yeah, but what is it? Is 9 cubed? It's 9 cubed on the bottom. So when you have negative exponents, that's the same as going like this. 9 to the negative 3 equals 27 to the negative 2. To make, remember, from grade 10 you were taught this? In order to make a negative exponent positive, you move it to the bottom. Or you move it to the other side. So if it's in the denominator, you'd move it to the numerator to make it positive. If it's in the numerator, you move it to the denominator. What's 9 cubed? I think it's 729. Isn't it? Is 9 cubed 729, or am I wrong? Oh. And then 27 squared, I must be 729. And we know we're right. How can I check it with my calculator? Do I check something that I've done, like down here, again, take it to the 3's? Do I y1, y2 then? Where do I y1, y2? The original. Could I move this 27x over, set it equal to 0, and then look for x-intercepts? Absolutely. You'd have to subtract it over. You can move these around, but I always just use my original. Okay. 3. 16 equals 1/2 x plus 4. So if I have a fraction, how would I go about making it not a fraction? What could you do? What did I tell you about negative exponents? You could move them down or up to make them positive, correct? But what about positive exponents? So 1/2 is literally just 2 to the negative 1, isn't it? I had 9 to the negative 3 was 1 over 9 to the 3, correct? If I had 1 over 81, that would be the same as 1 over 9 squared. How else could I write it? 9 to the negative 2, could I not? If I can make this not be a fraction, is my life a lot easier? Yeah. So I'm going to change this 1/2 to 2 to the negative 1. So I'm going to get 16 equals 2 to the negative 1. And what do I have to remember to do? Distribute it into the brackets, correct? So I have 16 equals 2, negative x minus 4. And now it's a lot easier to make a common base. What base could I make them both be? 2. I have to make them smaller. I cannot make them larger, correct? So 16 is 2 to the what? 2 to the 4. Now, if this is 2 to the something equals 2 to the something, what can I say after this? That those two must equal each other. So I get 4 equals negative x minus 4. Then what do I do? Add 4. Negative x equals 8. Then what do I do? Divide by negative 1. X equals negative 8. And what can I do to make sure I got this right? Check it. So I'm going to go 16 equals 1/2 to the negative 8 plus 4. 16, remember when you're checking what's on the left stays on the left, what's on the right stays on the right, checking is the same as verifying in trig. Bless you. So you're going to get 1/2 to the negative 4. Does that look the same? What can I do when it's negative? I can flip it. So what's on the top goes to the bottom, what's on the bottom goes to the top. So I'm going to get 16 equals 2 over 1 to the positive 4. What's 2 to the 4? 16. Number 4. What common base can I make it be? Can I put the 5 times the 2? The only way you can put bases together with exponents is if they're the same. Like if I had 3 to the x times 3 to the 2, I could put that together as 3 to the what? When I have 2 bases and 2 exponents, do I add them or multiply? When you have 3 to the x to the 2, what do? Multiply. So this is different. So what do you think I'm going to do? Write these as little side notes for yourself. So the only way you can put something together is if they have the same base. Do these? No. So I can't put them together. I can't make 5, 2, and 40 be the same base. But the 5 and the 40 both do not have exponents, do they? So could I put them together? Yes. If the 40 has an exponent, say it had an exponent up here, I would not be able to do common base. I cannot divide it over. But because it doesn't, I can go like this. 2 to the x equals 8. Now can I do common base? Yes. I repeat, if this 40 had a variable on it, like x plus 2, could I divide this 5 over? No. The only reason why I can divide them over is because both of them do not have an exponent. So 2 to the x equals 2 to the what? 2 to the 3. And so then this must equal this. So I get x equals 3. Then I assume I'm right? No, you check it. Where do I check it in? To my original question. If this was a written response, would I just start my question directly below the question in the question? Like where it's written? Like solve this, and then I just start working with their typed question? No. You will rewrite the whole entire question below. Not funny. You rewrite the whole entire question below, and then you solve it out. Same thing with a proof. You guys are going to get in trouble. If in the proof it says to prove that this equals this, prove that these equal, you have to take the actual question, rewrite it, and prove it equals. You don't just start on the next step where you're not proving anything. You didn't even tell me what the beginning was. You have to rewrite the question down. If you're like, nah, I'll be okay, then expect to lose marks. That's okay with you. If that's okay with you, I don't care. But you need to rewrite the question. You can't be lazy. Okay? So, we're going to check it. 5 times 2 to the 3 equals 40. 5 times 8 equals 40. 40 equals 40. Left side equals right side. Okay, this next one I would star. Because honestly, unless you're showing it, you won't even spot it. So I'm going to show it to you just so that if you do see it again, you might spot it. I don't expect that anyone would initially. 5. So I would star this one, because this one people forget about because it is weird. So there's number 5. 6 to the 2x minus 3 equals 1. It's under the common base question because I can make it a common base. Anyone have any idea how I could do that? No, because 1 to the 6 is what? 1. So originally, you might say 1 to the 6 because everyone says 1 to the 6, and then you do the math and you're like, oh no, that doesn't work. So I can't make the 6 be base 1. Can I make the 1 be base 6? 6 to the what is 1? 0. So I'm going to get 6 to the 2x minus 3. And anything to the exponent 1, or anything to the exponent 0 is 1. So if ever I'm equal to 1, I can always make them common base. It's going to be 6 to the 0. Because anything to the exponent 0 is 1. You're taught that in grade 10. So now I can go 2x minus 3 equals 0. Add 3. 2x equals 3. Divide by 2. X equals 3 halves. Now, those of you who are immediately turning it into 1.5 in order to check it, you should not do that. Because if you're in 30-1, your intentions are to do some sort of science or math in university, and they take away your calculator for the most part. So you have to be able to do your math. They for sure don't usually let you have these calculators at the least. They'll give you basic ones, but that's what it, if they do. I was only allowed a calculator for one class. So let's check it. 6, 2 times 3 to the 2 minus 3 equals 1. What's that original 2 over? 1. Why do we want to do that? So you don't try and distribute the 2 to the 3 and to the 2. Correct? The 2 goes times 3. When you multiply fractions, you do not need common denominators. Some of you are making common denominators. When you multiply fractions, you do not need common denominators. Multiplying fractions is the easiest thing. Top times top, bottom times bottom. If I was given any type of fraction to do an operation to, I would hope it would be multiplication. Okay? So I'm going to get 6 to the 6 divided by 2 minus 3 equals 1. What's 6 divided by 2? 3 minus 3 equals 1. 6 to the 0 equals 1. 1 equals 1. Until you have the exact same number, you cannot say left side equals right side. So I still have people going 6 to the 0 equals 1, left side equals right side. No matter, if I handed that to my daughter in grade 1 and I underlined it, and she's in grade 2, forgot she went up. If I handed it to her in grade 2, now she's really smart, and I said, hey, does this look like this? The 6 to the 0 like this, look like this? And she'd be like, no. Exactly. The answer to that is no. So you cannot write left side equals right side. Now if I said to her, hey, does this look like this? She'd be like, yeah, totally does. See? Okay. Even grade 2 could do that. Okay. Up in our game. What happens if I give this? Still common base. Don't remember what number I'm on. 6. But more advanced. So let's pay attention. 2 to the x minus 3 equals 4 times 32 to the x. It's not hard, I promise you. It's not. So, can we divide that 4 over like we did before we divided the 5 over? No, because everything has exponents. So, except for that 4, which is just going to sit alone. It's lonely. It can't go join anything. Yeah. If it has an exponent, you dividing it over isn't going to be helpful, because then when you multiply, you'll be dividing now and you'll have to subtract exponents, which is worse than adding. Yeah. So, we agree that I cannot divide that 4 over and make life easier. Not me. Sorry. Okay. And then I just immediately hung up on that human. I don't know who it is. Okay. Sorry, Jen. So, what base can I make them all be? 2. Okay. So we get 2 to the x minus 3. 4 is 2 to the what? 2 to the 2. And then I'm going to put a little multiplication symbol in here because I'm multiplying it by 32, which is 2 to the, close, 2 to the 5, I think it is, right? 2 to the 5 times x, so it's just 2 to the 5x. We agree? Let's go back to our rules up here. When I put them in the corner. When I have two bases that are the same, and they're being multiplied, what do I do with their exponents? Add them. You're all like, add, of course. And then homework, you're gonna multiply them. Don't, okay? Don't do that. So we're going to add them. We agree? So we're going to go 2 to the x minus 3 equals 2 to the 2 plus 5x. Had I moved the 32 over, it would be over here now, and it would be divided by 2 to the 5x, then I'd have to subtract the exponents, which is way more work, right? So I like try and keep them multiplying because adding to me is way nicer. But if you had division, you just have to subtract. Okay? Now we have common base, so we can go this and this. So we're going to go x minus 3 equals 2 plus 5x. Subtract x. Negative 3 equals 2 plus 4x. Subtract 2. Negative 5 equals 4x. Divide by 4. X equals negative 5 over 4. Then what do we have to remember to do? Check it. Make sure left side equals right side. Okay, I'm going to give you a couple questions, see how you do. Well, I'll give you one. We'll see how you do. Let's not get overboard here. Okay. This one's going to have a fraction in it. How do I get rid of fractions? No. How do I get rid of fractions? Put it to the negative 1. Thank you. Good job. Okay. Someone was listening. Oh, that's not 2. 7. 1 over 9, x plus 1, equals 3 times 81, 2x plus 1. I will give you a hint. You can make them all be base 3. But what's the first thing you're going to do? Take this to be 9 to the negative 1. And then you have to remember to distribute the negative 1 in. So you're going to get 9 to the negative x minus 1. So try doing this. So this is going to be 9 to the negative 1. Where do you think they're going to pick for the first answer? Forgetting to distribute the negative 1 through, work it out, give you an answer, right? So top common error, they'll have all your top 3. So we're going to go x plus 1. So will all of your unit tests. So it's going to be 3, 81 to the 2x plus 1. Okay? Then we distribute the negative through. Negative x minus 1 equals 3, 81 to the 2x plus 1. I told you can make them all be base 3. So we can go 3 to the 2. Next error could be not distributing the 2 in, right? And then 3, and then 81 is 3 to the 4, the 2x plus 1. And not distributing the 4 in and get an answer, right? But that's not actually where I think the common error is going to happen. I don't think you're going to mess up here, and I don't think you're going to mess up here. I think you're going to mess up in the next step. So you're going to get 3 to the negative 2x minus 2 equals 3 times 3 to the 8x plus 4. Where I think you're going to mess up is you're not going to put a 1 here. So you're not going to add the 1. Honestly, I think that happens as more of an error than the correct answer. Okay? So whenever I have a base, where you don't actually see an exponent, make sure to put an exponent of 1 so that you remember to add it. Okay? If you're someone who made that error, what do you do in your notes? Circle the 1 and leave yourself a little side note saying, don't forget to put a 1 when there's no exponent. I need to remember to add a 1. If you're that person, you need to leave yourself notes. In university, did your prof tell you that? No. You need to be good at making your own notes, right? So when you're writing it down, if you make an error, I would always circle the error and be like, hey, don't do this. Or something like that. Okay? So we're going to get 3 to the negative 2x minus 2 equals 3 to the 8x plus 5, not 4, right? Now, we can say that this equals this. Negative 2x minus 2 equals 8x plus 5. Add 2. Negative 2x equals 8x plus 7. Subtract 6x. Negative 8x equals 7. At the very least, if you remember how to check it, you'll catch yourself and be like, I messed up. I wanted it to be a negative. I don't know. Just to check if you're making sure you're doing what you're... Just screwed up. Okay, negative 10x equals 7. Divide by negative 10. That's why it's always important to check your answer, because at least you know then that you made a mistake, go back and try again. Just don't make an error in your check, because then you spend life trying to figure it out. Okay, one more type. This is the last one. This is also bringing back grade 10. Grade 10 comes back a lot, and quadratics and rationals from grade 11 never leaves. It's like there for life. Okay? So, Number 3, and we use this in grade 11. Often our grade 10 comes up in grade 11, and now it's also coming back up in grade 12. Okay, little side note. If your teacher gave you this, and they told you, we want to write a radical as a rational exponent. A rational exponent is a fractional exponent. Do we agree? What does the cube root of x to the 5? Wow, that was really hard to say. What do we do? How do we make these fractional exponents, rational exponents? You take the index, and index is the number that's under in the little check mark. It's called the index. So the index is a little number on the check mark. If there is no little number on the check mark, what's my index? A 2. And you bring it under the exponent. So this little bad boy comes under here. So I get x to the 5/3. That's it. That was a whole lesson in grade 10. It was rough. You cried a little, but you worked through it. Okay? So what if it doesn't have an index? You told me it's a 2. What if it doesn't have an exponent? What is the exponent? A 1. So what is the square root of 8 as an exponent? 8 to the 1/2. Often when they write these, they'll write it as 2 brackets 16x plus 1. I always write it with a little dot in between in hopes that that reminds me that I'm multiplying. Okay? Now what can I do? Common base of 2. Yeah. So I'm going to have 2 to the 3 to the half. What happens when I have 1 base 2 exponents? You times them, you multiply them. And I'm going to put the 3 over 1 so that I don't try and put the 3 to both the 1 and the 2. Okay? 2 is to the what? 1. I have to remember that exponent. Times 16 is 2 to the 4. And I have to remember to distribute. So I'm going to get 2. And when I multiply fractions, I multiply across the top, across the bottom. Numerator times numerator, denominator times denominator. So it's going to be 3 over 2 equals 2 to the 1 times 2 to the 4x plus 4. Then what can I do? 2 to the 3 halves equals 2 to the what? 4x plus 5. We add exponents. And now 2 to the this has to equal 2 to the this. So I'm going to get 3 halves equals 4x plus 5. And no, I'm not going to use the math enter button, because when that calculator is ripped out of your hands in calculus or in other places in university, you need to be able to do it. Subtract 5. So we have 4x equals. Guys, what do we have to do in order to put those together? This is good practice for proofs and verifying. Common denominator. Multiply by 2. So we get negative 10 plus 3, negative 7 over 2. And then I'm going to do something weird. I'm going to go like this, divided by 4. What did I tell you to do when it looks like that? Not write it like that. Write it sideways. So I'm going to get negative 7 over 2 divided by 4 equals x. Then what do I do? Negative 7 over 2 times a quarter equals x. So x equals negative 7 over 8. You should easily be able to do this. If you can't do this, verifications and proofs is impossible. Because that is what the steps are in verifications and proofs of trig. Except as coses and sines and tans, which would be more complex. Can we check this? Yes. Plug it back into the original, see if left side equals right side, or y1, y2. Now what happens if y1, y2 we get a decimal? How can we turn it into a fraction? Because right now your calculator isn't ripped out of your palms. You just go second trace 5 enter, 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 and get your x, y value, right? Then you go to your main screen, and you go x, enter, and then the decimal pops up for that answer. And then math, enter, enter. Okay? So I'm going to give you about 15 minutes to work on the next bit, and then we're moving on. So that's your homework. Solving without common base. Part 1. I think so. Oh, no. That's just for the computer. Solving without common base. So say I give you, come back. There we go. Solve. 3 equals 5 to the x. Let's do a basic one. The only ones, that's why I said part 1, the only ones we're going to look at right now is if you can't make common base and there's one exponent. If there's 2 exponents, totally different ballgame, which we'll do later. But if there's one exponent, if you can't find common base, one exponent, and you cannot find common base, convert to a logarithm. Now, how in the heck do we do that? So, we have 3 equals 5 to the x. How do we convert to a logarithm? Well, this is the base of my exponent. We agree? It's the base. That's what's called, the base to the exponent. The base of your exponent becomes the base of your log. So, we are going to have the word log for logarithm. The base of the log is the lower number. It's not in line with log. It's like a little subscript. So I'm going to get a 5 down here, because that's called the base of my log. Okay? Base of the exponent becomes the base of the log. And what's with it doesn't stay with it. So what's friends here with exponential? The 5 and the x. So what's friends in exponential will not remain friends in logs. So what's friends here is 5 and x. So the 3 is now going to join that 5. So the base of my exponent becomes the base of my log. The 3 gets written beside. Now they're friends. They become friends. Ones who are friends do not stay friends. And then it equals the exponent. And as an exact value, we'd stop. That would be our answer. But if they ask to the nearest tenth, we have to be able to plug this into our calculator. Okay? Now, there's some of you who have a log base button. Yay. Some of you who do not have a log base button. So you have to do a bit more work. So if you have one of the calculators where your exponent pops up, you have a log base button. If you have a calculator where you just have the little like roof symbol, yours does not pop up. So if you do not have the log button, this is what you're going to do. So if you have the one where the exponent doesn't pop up, you're going to do this. If you have the one where the exponent does pop up, let's try it out anyways, because it works for every single one. So we have log base 5 of 3. What we can do is we can just draw a line through it like this and add a log to the bottom. So when you type it into your calculator, it's going to go log, and it's going to open up a bracket, 3, and what are you going to have to remember to do? Close it. If not, you're doing log 3 of log 5, which is really messy. So you're going to go log 3, close bracket, divided by log 5. Give me to the nearest tenth. What do you get? So 0.7. Now, if you're someone with a log base button, the log base button, you press it and it pops up and it leaves you spots to put the numbers. Okay, so if you have that, you're going to go math, where the fraction button is. You're going to go math and you're going to arrow up. Arrow upwards because it'll get you to the bottom faster. And then I think it's letter A. Is it letter A? And when you press that, it looks exactly like this one, and you just put the numbers in it. Scares me. Okay, did you get 0.7? Yes, so it shows that it actually does work doing this. Okay, now some people try and swap these. Don't. Just write your base lower, draw a line through, and put a log with the base. Okay, that's how you can divide them. And then I have an answer. So if I couldn't do common base, and I have one exponent, I can convert it to a log. We agree? Okay. So what if I have common base will be easier. This is easier if there's only one exponent. If there's two exponents, common base is easier if you can do it. If you can't do common base, you have to log both sides and do a whole bunch of rules. But if there's one variable, often log base is actually easier. Okay, so say I have 2 times 6 to the x plus 3 equals 10. If you're like, there's one exponent, so I can convert it to a log, and you're like, log base 6 of, oh, what? It's probably not in the best form. So what could we do? We can divide the 2 over only because what? The 10 and the 2 both do not have exponents. Well, they do. They technically have a 1, but that's it. So we divide by 2. And now we get 6 to the x plus 3 equals 5. For those of you who think now if I y1, y2, I did algebra, no, you're still graphically solving it. You didn't do algebra. Like, you did a tiny bit of algebra, but you didn't solve it algebraically. Okay? So I don't think you did. You actually, if they say solve this algebraically, you have to convert it to a log. Okay? So how do we convert to a log? We're going to go, the base of my exponent becomes the base of my log. So I get log base 6. And what's with it currently? X plus 3. So I ain't staying with it. So what's going to be beside the log? A 5. And what's it going to equal? Exponent. That's why you convert to logs, because it gets the exponent to be flat, right? It no longer is the exponent in the exponent. And now we want to get x by itself, so it's one little extra step. Subtract 3. Now that if I subtract 3, I'm going to go plus log this. Could I go subtract 3 plus log 6,5, or could I go log 6,5 minus 3? Would that be different? It's not different, but if you're the person who's dividing them out, make sure that you put them in brackets, then subtract 3. I just do it this way so I don't have a problem. So as an exact value, this would be my answer. Log 6, 5 minus 3, like this. Do you see how this could join the 5 and then you have problems? Is this 3 with the 5? No, it's technically like this, yes? So I always like putting it in this way so I don't mess up and accidentally put it in with a log, but that's just me. If you have a log base button, you won't, because you won't add it to that log. So type it into the nearest tenth, what do you get? Negative 2.1. Now, if I plug negative 2.1 back in, left side will equal right side? No, because the answer is actually not negative 2.1. It's negative 2.101 some left, right? So if I wanted to plug it back in, I have to plug back in this whole thing to see if it works. Correct. You could save it as like a store it as a value, or if you have the button where you can push up, then it'd be okay. All right, so I have a few little questions on that. This is like very, very basic solving, so there's not a lot of questions.